In this next lesson, we're going to talk about a new theorem called the triangle proportionality theorem. And this theorem says that if a line is parallel to one side of a triangle, so here we have triangle ABC, so if DE, that side, is parallel to this side AC, and if DE intersects the two other sides of the triangle, then that means that that line divides the sides into segments of proportional lengths. So therefore, if DE is parallel to AC, then that means that these little segment parts of the triangle are proportional. So we could do BD over DA would be equal to BE all over EC. So the two little parts of these triangles now are proportional to each other. Now the converse of this theorem, which means flipping the hypothesis and the conclusion, would say if I know that BD over DA equals BE over EC, if that is given to me, then I can conclude that that line DE is parallel to the line AC. Okay, let's look at some problems together. Number one, find the value of X. So if we look in this triangle, we have two lines that are parallel, and this parallel line intersects the two sides of the triangle. Therefore, I can take each section, and these sections are proportional to each other. So I can say 12 over 14 equals 15 over X. And then, like we've been doing, you would just cross multiply. 12 times X is 12X, and that would equal 14 times 15 is 210. Divide both sides by 12. And that means that X is 17.5. Remember, it is okay to get a decimal for a side length. Okay, looking at number two. Again, if my lines are parallel, and they are, that means that these segments are proportional. So I can say X over 18 equals 56 over 21. And again, doesn't matter, you could have done 18 over X, but whichever order you do the first ratio in, you got to do the second ratio in that exact same order. Cross multiply. 21X is going to equal 56 times 18 is 1008. I'm going to divide both sides by 21. And I get that X is 48. Okay, let's look at number 3 now. This time they don't give me each section, they give me one of the sides, they give me the whole length of it. Well, I can still find out this segment. If the whole thing's 45 and this segment of it's, the whole thing's 55 and this segment's 45, that means that this smaller segment has to be 10. And therefore now I can set up my proportion. It would be X over 36 is going to equal 10 over 45. I'm again going to cross multiply. 45X equals 360. Divide by 45. So 360 divided by 45. X is going to be 8. Okay, I'm going to skip 4 and I'm going to move to 5. Here in 5, we're doing the same thing. We have two lines parallel, except they throw in an expression for one of the sides. But we're going to do exactly the same thing. We've been working with proportions with expressions in them. Parallel lines, so these portions are, or segments in the triangle are proportional. So 30 over X plus 7 is going to equal 25 over 15. Again, I'm going to cross multiply. This is going to give me 25 times x plus 7 equals 30 times 15 is 450. Okay, so that's going to give me 25x plus 175 equals 450. I'm going to subtract that 175 over. I get 25x equals 450 minus 175 is 275. I'm going to divide both sides by 25. And that gives me that x equals 11. Okay, I want you to pause the video and I want you to try 4 and 6 now. Okay, now let's look at the converse of the triangle proportionality theorem, which says if I know that my sides are proportional, then I know that those lines are parallel. So in number 7, we're trying to determine, is MN parallel to JL? So in order to say that they are, my sides have to be proportional, which means they have to have the same ratio. So I'm going to set up 11 over 15.4. And I'm going to find that ratio, 11 over 15.4. I'm just going to take in my calculator and divide it. And that is about 0.714. And now I'm going to try this one. 10 over 14. And if I plug that into my calculator, I do get 0.714. I get the exact same thing. So are these sides proportional? Yes, because they have the same ratio. Therefore, I do know that MN is parallel to JL. I can prove that because my segments are proportional. Okay, you try 8 and 9. Okay, the next part of your notes is about proportional parts and parallel lines. So it says if 3 or more parallel lines, here we've got A, B, C, D, and E, F are all parallel. If these lines intersect 2 transversals, and we have 2 transversals here, then they cut off the transversals proportionally. Okay, so that means that if AB is parallel to CD, and those 2 are also parallel to EF, because you have to have 3 sets, then that means that AC over CE is going to equal BD over DF. So still just setting up proportions. Okay, let's look at number 10 really quick. Do I have 3 sets of parallel lines? Yes. Are they cut by 2 transversals? Yes. So I can find X, excuse me, very easily, setting up that proportion. 45 over 18 equals 52 all over X. Cross multiply 45X equals 52 times 18 is 936. Divide by 45. And X is 20.8. Again, it is okay if you get a decimal. Okay, you pause the video for a minute and you try number 11. Okay, let's look at 12 together. Again, you have 3 parallel lines cut by 2 transversals, so we're still going to go through and set up proportions, except this time you know the whole length from one end of the parallel line to the other. Very easy, we can find that missing link. All we have to do is 32 minus 18, and so I know that this link is 14 there. So I can set up a proportion. X over 27 equals 14 over 18. Cross multiply 18. X equals 378. And then divide by 18. And that gives me 21. Okay, you try 13. Pause and try 13. Okay, looking at 14. Again, same thing, except we're just throwing in an expression. We have 3 parallel lines cut by 2 transversals, so proportion. 24 over 18 equals 3x plus 1 over 12. We're going to cross multiply. 18 times 3x plus 1 is going to equal 288. So now I'm going to distribute the 18, and that's going to give me 54x plus 18 equals 288. Subtract that 18 over. So we get 54x equals 270. Divide by 54. 270 divided by 54. X is 5. Okay, you try number 15, and then we will talk about all these that you did in class tomorrow.